Welcome to the another problem solving. The question number 16 in the unit number 2 of the first law, and the question number 3 in the open system. Let's read out this question and try to solve it. In a steady flow system, 135 kilojoules per kg of work is done on the by the system. The specific volume of the fluid, pressure and velocity at the inlet is 0.37 meter cube per kg and 600 kilopascals, and the velocity is 16 meters per second. The inlet is 32 meter above the floor level. The discharge conditions are 0.62 meter cube per kg. And next is pressure is given as at the state to 100 kilopascals and 270 meters per second. The total heat loss between the inlet and discharge is 9 kilojoules per kg. The fluid, does specific internal energy increase or decrease? If so, by how much? The outlet is at the floor level. Okay, so this is the question, which is a simple problem, which by simple substitution of the formula will get the solution. Let's try to solve it. First, try to write the given data and draw the sketch, and then to find and then write a formula and substitute the values in them, and we'll try to calculate the final internal energy. Okay, so first is the given data. It's sorry, it's state 1. It's state 1, d dash w by dm, which is given in as a mass base one, 135 kilojoules per kg, and specific volume is given at state 1 as 0.37 meter cube per kg, and V1 is given as 16 meters per second, and P1 is given as 600 kilopascals. Okay, so this is at state 1. Next, it's state 2. Specific volume is given as 0.62 meter cube per kg, and P2 as 100 kilopascals, and V2 as 270 meters per second, and Z2 as 0, and here Z1 as 32 meter. Okay, so this is what is we need to find. What does we need to find? Internal energy. Okay, so here first let us draw the sketch now. Let us draw the sketch. So here is your section 1 and here is your section 2. This is your control volume. There is some work which is being out, and there is a Q which is being given here. Okay, and this is your control surface. Okay, so this is a sketch, and next is write down the formula to calculate what is the formula. D dash Q by dm plus h1 plus v1 square by 2 plus z1 is equal to d dash w by d plus H2 plus V2 square by 2 plus ZZ2. Okay, so this is a formula. Now just simple substitution of this, then you'll get the value. So here H is equal to U1 plus P1 V1. Enthalpy is not given directly, so H is equal to U1 plus P1 V1. As you know, U1 minus U2 is equal to P2 V2 minus P1 V1 plus V2 square minus V1 square by 2 plus Z2 minus Z1 into Z plus d dash W by dm minus d dash q by dm. Why I have written in this form is because to find the internal energies. That is the case I have written the formula in terms of your internal energies. Next, substitution of these values: 1 into 0.62 minus 6 into 0.37 into 10 square, because conversion of the units, plus 270 square minus 16 square by 2000, conversion of the units into kilojoules, plus minus 32 into 9.81 into 10 to the power of minus 3 plus 135 minus of minus 9. Okay, so this is the value. 9 is because heat has been rejected. And next, by simple substitution of this, then you'll get the values as minus 160 plus 36.45 minus 0.314 plus 135 plus 9. Okay, so finally by this we'll get the value as internal energy, that is change in internal energy, is equal to 20.13 kilojoule per kg. So this is the final value which I have got. So in this, specific internal energy will decrease by 20.13 kilojoules per kg. Okay, hope the solution is clear to you. It's very simple. Then by substitution of the values into the formula, we'll catch you in the next section with another problem. Thank you.